All right, what's up, Joel? So today you're going to be learning about comparing linear, exponential, and quadratic functions. So I'm going to go ahead and jump in. If you have any questions after this, please let me know, and then you can start the activity. All right, so let's kind of start with a real-world application. The table shows the amount of money in dollars that a bowler pays for bowling games. Determine the type of function that best represents the situation. Write a function that models the data. How much does it cost to bowl 11 games? So if we're looking at this, the first thing we want to check is kind of look at the information that we need, right? So we see that we are adding by 1 on the top, which means it is consistent. So far we're leaning toward a linear function. And the bottom is also consistent by adding 3 each time. So therefore we're going to be learning a linear function, which means it's going to be y equals mx plus b form. So first we've got to find that slope. And so because it's changing at a constant rate, we can first, let's look at that y-intercept and see if we can find that y-intercept. And so anytime your x-axis is 0, that means your y-axis is going to be your y-intercept. So our y-intercept is going to be plus 4. And then now we can go from there and find our slope by doing our slope formula, y2 minus y1 over x2 minus x1. Pick 2 points that you want to use. I'm going to go ahead and use 1, 7, and 2 and 10. Subtract, and you'll go ahead and find that y, or that slope, okay? And then we can go ahead and find how much does it cost when you bowl 11 games. So replace x with 11 and find that it'll cost $37 to bowl 11 games. So with this, let's kind of look at what we're learning about today. So identify linear, quadratic, and exponential functions using graphs or tables. Compare graphs and linear, quadratic, and exponential functions using graphs or tables. And we're going to also look at some real life situations. So first, let's look at our definitions. Remember that linear functions has to pass that linear or vertical line test and is in y equals mx plus b form. Linear functions are lines. Exponential functions are when you have a curve in your line. And we haven't necessarily talked about this yet, but we're also kind of looking at math 2 right now. When you have a curve that is in y equals a b, and then your x is always that exponent. And that's why we get a curve, because we're looking at exponential functions, which means we have exponents in our equations. And then finally, you have quadratic functions. And quadratic functions we've kind of looked at a little bit, but it's when you have y equals x squared plus x plus c. And then a and b are those numbers that are given to us when we're looking at these specifically, and those are called parabolas. So let's kind of look at this first and plot the points, tell whether the points represent a linear or an exponential or a quadratic function. So let's kind of plot these points and see what we get. So if we plot 5, 5, 1, 1, 3, 1, negative 5, 1, 5, and then 2 and 1/2, you're going to get something like this. And so is this linear, is this exponential, or is this quadratic? And I'm hoping you're leaning toward quadratic as we are getting a parabola here. So it is a quadratic function. Let's plot these points: 2, negative 3, negative 1, 3, 0, 1, negative 2, 5, and 1, negative 1. I'm hoping you're looking at this and seeing that we're getting a straight line, which means it's going to be a linear function. And then the last one here, let's go ahead and plot these: 3, 8, 0, 1, 1, 2, negative 1, 1/2, and then 2 and 4. Because we're going to get a slight curve in our graph here, we are actually looking at a exponential, okay? Again, let's kind of keep practicing. Let's plot these points here. And we're getting something like this. Because it's a straight line, we are going to have a linear function. Let's plot these points here. Okay, we're getting a curve, which means it's parabola, which means we have a quadratic function. Let's go ahead and plot these points here. We're getting a slight curve here, which means we have an exponent, which means it is an exponential function. And so I'm hoping you have that definition. Anyways, let's keep moving on. So we have official definitions of linear functions here. We already know these quite often. But if you remember linear functions, we want to have a constant rate of change on both your x and y axis here. So our official definition is the y values have a common difference of +4, so the table represents a linear function. Okay, as long as you have a constant distance or a constant rate of change on both your x and y, you will have a linear function, and that's always going to be y equals mx plus b form. Exponential functions. Okay, if I run out of time, Joe, just watch the next video. But exponential functions is when you have an exponent and your x is in an exponent form.